All right. How would I start this warm-up? Add 8. Good. This is one of those and problems we looked at yesterday. So if you add 8 in the middle, you can do it on the left side and the right side all at the same time. You don't have to break it up into two separate problems. Then what? Divide by 3. Good. So I have 2 less than t less than 6. This said solve and graph, so I'm going to draw a number line. I always put 0. It's a good reference point. Then I'd have 2. Then I'd have 6. They're both open circles since these aren't equal to, and since it's an and problem, I'm going to shade in the middle. T is in the middle of 2 and 6. Not right in the middle, but anywhere in between there. Here's our section number for today. It's 1.7. It's all about absolute value equations and inequalities. We skipped section 1.5, as you guys remember. So this is the last section in the book, but we're actually going to do one more tomorrow. We're going to move back a couple and finish 1.5, and then we will be done with chapter 1. Whenever you're talking about absolute value, the main thing to remember is we're talking about a distance. It's the distance a number is away from 0 if you're looking at a number line. So I have a question about distance. Do you hear people express distance as a negative number? Like I drove -5 miles to Millstadt. You would not hear that. Okay, distance is always positive. So is absolute value. Now, when you say always positive, that's kind of misleading because it could be 0. So a better way to say is it's just never negative. So absolute value is never going to be negative. Any questions on the idea of absolute value? Here's a review of an easy problem. So I'm saying the absolute value of x equals 5. So that's saying x is 5 spaces away from 0 on the number line. What are the two numbers that are 5 spaces away from 0? 5 and -5. So those are our solutions here. Any questions on that idea? Now, if you put an equation in there and it's written in black, I don't know. This slide just randomly popped up with a different background. I'm not really sure what's going on. I'll make it a little easier for you. Now you don't just have a variable, you have an expression. So this expression is going to be 7 units away. So that expression could either be equal to 7, that's 7 units away from 0, or -7. Okay? And these actually pop up. If you can't see my writing, I'll just go to the next one. Can you guys see those? No. All right, I'll highlight them. Sorry again, technical difficulties. So the first one, it's just what I wrote earlier. X plus 2 equals 7, or x plus 2 equals -7. Now we can solve those. So you have to solve them independently. We could get x as 5. Over here it's -9. And of course, if you plug those into the original, if you plug 5 in here, you'd get 7. The absolute value of 7 is 7. If you plug -9 in, -9 plus 2 is -7. The absolute value of -7 is 7. So that's how this one works out. What are your questions? So this problem says we're going to take it up a notch. The main thing to know here is that you can't set up the positive and negative options like we were just talking about until the absolute value is by itself. So the first thing you want to do here is get rid of that adding 5. We can't do anything while that adding 5 is next to the absolute value. So what can I do with it? Subtract it, of course. So I have the absolute value of 2x minus 6 equals 10. Now what would you do?
2 minus x equals 10. 2 plus x equals 10.
Ooh, close. You don't change that sign. You just change the sign on this side. So it's going to be 2x minus 6 equals 10, and 2x minus 6 equals -10. Don't change the expression inside the absolute value. You just change what it equals. All right, now we can solve those. So we'd add 6. 2x equals 16. X equals 8. 2x equals negative 10. Whoa. Negative 4. X equals negative 2. And again, you can check these answers. These both work out. I've already done it. Any questions? Very good. We start this one by dividing by 2. So the absolute value of x minus 7 equals, over here we have to divide each term by 2, so that's 3x plus 1. Now this one gets a little trickier at this next step. Normally we set up the positive option, then we set up the negative option. However, we have to make the whole right side negative. You can't just make the 3x negative. So in this case, we have to distribute the negative sign. So be aware of that. If you have more than one term equal to the absolute value of something, you have to make all of them negative or switch the sign on all the terms. Now we can just solve like normal. So I would subtract x. Negative 7 equals 2x plus 1. Subtract 1. I'm coming up with x equals negative 4. Over here I'm going to add 3x. 4x minus 7 equals negative 1. Add 7. 4x equals 6. Divide both sides by 4. Sorry, you can't see what I'm writing. So right now I have 6 over 4. This is kind of like what we talked about on the quiz the other day. I don't want you to make that a decimal. I would prefer it just as a fraction that's simplified. So 2/3. Now, we're not quite done with this one, but I'm going to stop you guys here. Do you have any questions? Okay. You will notice this is the same problem, but now the directions say check for extraneous solutions. Extraneous solutions are solutions that appear that aren't really solutions. So we came up with x equals, what is it? Negative 4 and 3/2. Good. So I would advise you to check for extraneous solutions anytime you do something that feels a little weird. That's what I always tell students. So did it feel kind of weird like making one whole side negative? To me that felt kind of weird. I don't know. Sometimes when you square both sides it feels kind of weird. Anytime you do something that you're not used to doing, it might introduce these extraneous solutions. So anytime you're not quite sure if what you're doing is legal, go ahead and go back and check to see if it works. So we are going to plug in negative 4, and we're going to plug in 3/2, and we're going to see if they work. Sometimes they both work, sometimes neither of them works, sometimes only one works. So this is going to be 2 times the absolute value of negative 11, which is just 11. So I'm coming up with 22 equals negative 22. Does that work? No. So this is actually not a solution. Okay? Next you would plug the other one in and double check. I'm going to ruin the fun for you though. This one works, okay? So you can use your calculators. You'll be a little quicker than I am by hand. But I checked earlier today. It absolutely works. So I will let you guys check, or you can just take my word for it. That is a solution. Negative 4 is not. What are your questions? Again, we call these extraneous solutions. So if they work, keep them. If they don't work, just cross them out. They are not part of the answer. All right, we're going to leave absolute value equations. Now we're going to talk about inequalities. anytime you have an absolute value inequality, you're going to end up with one of those compound inequalities we talked about yesterday. They're either going to be and problems or they're going to be or problems, and we have to find out which one. It's pretty simple. I have a memory trick for you, but it is kind of important to talk about why it works this way. So, I just want to explore the idea of distance being less than or greater than. So, I'm going to draw you guys a picture. Bear with me. I'm not a very good artist. So, every morning I run 2 miles before school, believe it or not. So, this is me. I wear like a reflective waistband because it's always dark out. Or a little sweatband because, you know, why not? I'm running. Okay, so that's me running. And this is an absolutely true story. The first day of school I'm running, you will never guess what happened. I almost ran into a deer. Like, my body and a deer's body, we almost collided. I wasn't in a car, I was running. And it was a big deer. Okay, so this is my story. Now, let's make it math appropriate. I'm going to draw a number line under me and this deer. I'm going to play the role of 0, okay? So I came to school and I was all hyped up because I just almost had this encounter with a deer. It smelled. It was very startling, okay? And I remember telling my coworkers I was less than 5 feet away from this deer. The distance between me and this deer was less than 5 feet. So if I was going to draw a number line, this is 5 and this is -5, where could the deer have been? If I said the deer was less than 5 feet from me. It could be below 5, right? Could it have been in the other direction? Yeah, and I mean, really, there wasn't a number line on the street, but same situation, okay? If you say something is less than 5 feet, or 10 feet, or 12 feet, that means it's close to you, right? That would represent an and problem. Does this make sense? Let's think of another situation. It was very scary, actually. What's a situation where you'd say, like, oh, it was at least 10 yards away? A football. Okay, so now you're the quarterback, okay? So this is you. You're throwing a football. Oh, it looks like a pizza. Okay, you know what I'm saying. Oh, and this is a good example. So, okay, you're a football player. Imagine. Okay. You're on the 0-yard line. That's right in the middle, right? Is there a 0-yard line? How does it work? 50-yard line. Okay. Let's pretend it's called the 0-yard line. Okay, let's just pretend for my example it's the 0-yard line. Don't tell anyone how. Don't tell Mr. Stevens how bad I'm at that. Okay. All right. So you are throwing the football and you're like, oh, he's at least 20 yards away. So if this is 20 yards away, where would the person be? Farther away, right? He'd be down this way. Where would 20 yards away be in the other direction? It'd be facing out, right? So if you're like, oh, he's greater than 20 yards away, that looks like an or problem. From yesterday, remember the ors? If you're like, oh my gosh, this deer was less than 5 feet from me, that looks like an and problem. Okay? Make sense?
Yes.
Okay. Sorry, I'm the worst artist in the world. All right? We can translate this to a number line, of course, in math. So if I wanted to say that this expression was greater than 12 units from 0, it could be away starting at 12 or at -12. And again, we discuss how this appears to be an or problem. Make sense? So I like to change the words a little to help me remember. So if it's a less than problem, I like to think of it as less than. It's an and. Okay? Great or, it's an or problem. That's going to help you, okay? So don't think of less than, think of less than. Don't think of greater, it's great or. Don't spell than and greater like that in your English classes, but in here, go for it. It'll help you. All right, and then just a reminder, this only works, you can only set up the 2 different statements we're about to do when the absolute value is by itself. So if it's not, that's always your first step. So using my memory trick, greater or great or, this is going to be an or problem. Now we can set up our two scenarios. So the absolute value greater than 12. So basically you just drop the absolute value symbols. X plus 5 can be greater than 12. Now it gets a little harder with inequalities than equations because when you set up the negative option, you have to flip the symbol. And again, if you think of what our graphs look like in our examples, that makes sense. If it's an or problem, you want it to be going less than your negative and greater than your positive. Okay? So these are the two inequalities we have set up. Now we can solve them. So subtract 5. We get x greater than 7. Or x less than negative 17. Now, if you wanted to rewrite them to have the smaller one in the front, you can. I told you guys yesterday for or problems, it's kind of up to you. And there's a very specific way to write them, but on these, it's not a huge deal. I'm going to start at negative 17. It's less than, so I go left. Also start at 7. It's greater than, so now I'm going to move right. What are your questions? All right, here's our next example. Is this one going to be an and or an or? An and, because it's less than or equal to. Okay? So I know I'm going to have an and. The first option is always easy to set up. The second one is where we have a little problem. So change the way the symbol is facing. If it was less than or equal to, now it's greater than or equal to. And change the sign of the number on the right. Just like last one, we can go ahead and solve them. It's going to be x less than or equal to 22. And x greater than or equal to negative 16. Now, and problems we write in a specific way, and we don't use the word and. You always start with the smaller number, which in this case is 16. Negative 16, excuse me. And x is bigger than that, right? So I would need a less than or equal to symbol, then my x, then another less than or equal to symbol, and finish it off with the big number. I told you guys yesterday, when you write it this way, it's super easy to graph because we can see that x has to be bigger than negative 16, but smaller than 22. So put the negative 16, put the 22. These are going to be filled in because they are or equal to. And then it's going to be in the middle. What are your questions? And or? Or. Why or?
Because it's great or.
Because it's great or. Good. See, I told you guys that would come in handy. All right, set them up. Don't forget on this one, we have to flip the symbol and change the sign. From here, it's pretty simple. I'm coming up with x is greater than 10 over 3. Or x is less than negative 2. So this is my solution. Again, if you want to take the time and write it with the smaller one in the front, that's fine. I am not too particular on the ors. We want 0 on the number line. We want negative 2 on the number line. We want 10 thirds, which is like 3 1/3, so kind of put it off to the right. Both of these are going to be open circles. It's less than the negative 2, so I'm going to go left. It's greater than the 10 thirds, so I'm going to go right. What are your questions? So I want you to think back to the first thing I told you today about absolute value. Absolute value is never negative. Or you said always positive, but we know 0 is in there too. So it's never negative. Always 0 or more. So, in this problem, I'm saying 0 or more is greater than -5. Can anyone think of a time that's not true? Can anyone think of a number we could plug in for x that would make this a false statement? So we're saying 0 or any positive number is greater than -5. Did you say you had one? Well, if I plug 0 in there, I'd have 0 plus 3. The absolute value of 3 is 3. 3 is greater than -5, right? Yep, that's a good guess. There are actually no numbers you could plug in there. Because think about it. If you got, let's say, a -20, when you take the absolute value, it would be a positive 20. If you put something in here that made it 0, 0 is always still going to be greater than a -5. So, basically, I'm telling you, any number you plug in here, when you take the absolute value of it, it's going to be bigger than -5. Does this make sense? Anytime any number works, what do we say is the solution? All real numbers. Great. What would the setup have to be to get no solution? What do you think? So we'll use the same numbers. Is there any sort of symbol that I could use that would make it no solution? Equals would definitely have no solution. Or less than. Less than would have no solution too, because think about it. You're saying a number 0 or more is less than -5. Would that ever happen? A number greater than or equal to 0 is less than -5. That would never happen, okay? So in this case, equal to or less than would both be no solution. All right, you might see a couple of those pop up on your homework in the test next week, so just be aware of those. Any questions? Here's your homework. It is written on your green sheet. Again, it's only odds. Let me know if you guys have any questions.